Have you ever wondered what makes some plants toxic, some medicinal, and some just outright addictive? The answer lies in a fascinating group of compounds known as alkaloids. These natural chemical warriors, found in over 20% of plant species, wield enormous power over our bodies and minds. From the caffeine that jolts us awake to the morphine that dulls our pain, alkaloids are a constant, unseen presence in our daily lives. So, if you're ready for a journey into the world of alkaloids, stick around, you're in for an enlightening ride. Before we dive in, it's essential to understand what alkaloids are. To put it simply, alkaloids are naturally occurring organic compounds that contain at least one nitrogen atom in their structure. This might sound like a mouthful, but consider this. These compounds are the chemical backbone of many of the substances we encounter in our daily lives. From the caffeine in your morning coffee to the morphine used in pain management, alkaloids are all around us. These compounds are typically derived from plants, but they can also be synthesized in the lab. They have a basic structure, which means they can accept protons due to the presence of a lone pair of electrons on the nitrogen atom. This basicity is a key property of alkaloids, and it's part of what makes them so diverse and versatile. In essence, alkaloids are naturally occurring compounds with significant effects on living organisms. They are a fascinating group of compounds that play a crucial role in both nature and human society. Alkaloids are not all the same. They are classified into different groups based on their chemical structure. These fascinating compounds are characterized by their nitrogen content and are broadly divided into four main categories: true alkaloids, proto-alkaloids, pseudo-alkaloids, and polymeric alkaloids. Let's start with true alkaloids. These are the traditional alkaloids that most of us are familiar with. They derive directly from amino acids and are usually made up of heterocyclic rings containing nitrogen. The alkaloid morphine, for instance, is a true alkaloid derived from the amino acid tyrosine. Next on the list, we have proto-alkaloids. Unlike true alkaloids, proto-alkaloids are not derived directly from amino acids. Instead, they are synthesized from simple precursors such as phenylalanine or tyrosine. They are simpler in structure than true alkaloids and contain nitrogen, but not within a heterocyclic ring. A well-known example is the stimulant ephedrine. Then we have pseudo-alkaloids. These are a bit of a wild card. They don't fit neatly into the other categories. Pseudo-alkaloids are not derived from amino acids, and their nitrogen atoms are not part of a heterocyclic ring. Instead, their nitrogen comes from a different source, such as transamination. The popular stimulant caffeine is a pseudo-alkaloid. Finally, we come to polymeric alkaloids. These are complex alkaloids formed by the polymerization of simpler alkaloids. They are relatively rare compared to the other categories, but they are still important. An example is the alkaloid conine, found in poison hemlock. This classification helps scientists understand the effects and uses of different alkaloids. It's a bit like a map, guiding us through the complex world of these nitrogen-rich compounds. By understanding their structures and origins, we can better appreciate their roles in nature and in our lives. Whether it's the stimulating effects of caffeine or the pain-relieving properties of morphine, the diversity and complexity of alkaloids continue to captivate and challenge chemists around the world. And remember, subscribe for more because you won't find me later. Alkaloids are found in a variety of places and possess unique properties. Let's delve deeper into their occurrence and properties that make them so fascinating. Firstly, alkaloids are predominantly found in nature, specifically in the plant kingdom. They occur in around 20% of plant species, which is quite a significant proportion. Some familiar plants that contain alkaloids include poppies, which produce the powerful opiate alkaloid called morphine, and nightshades, which yield the notorious alkaloid atropine. Interestingly, not all alkaloids are confined to plants. Some are also found in animals, fungi, and bacteria. Now let's explore the properties of alkaloids. These compounds are known for their bitter taste, but their most intriguing characteristics extend far beyond this simple sensory experience. One of the key properties of alkaloids is their toxicity. Many alkaloids are poisonous and can have harmful effects on humans and animals. This toxicity is often used by plants as a defense mechanism against herbivores. But it's not all doom and gloom. Despite their toxicity, many alkaloids have medicinal properties. They have been used in traditional medicine for centuries and continue to be utilized in modern medicine today. For example, morphine, derived from the opium poppy, is a potent painkiller. Quinine, another alkaloid, is used to treat malaria. In addition to their medicinal properties, some alkaloids have psychoactive effects. They can affect the human brain and alter perception, mood, and consciousness. Examples include caffeine, which stimulates the central nervous system, and mescaline, a psychedelic found in certain cacti. These properties make alkaloids a topic of great interest in various fields, from medicine to agriculture. Their diverse occurrence and wide-ranging properties underscore their importance in our world. They serve as a reminder of the intricate and fascinating chemistry that exists in nature. Our exploration of alkaloids will continue in the next scene, where we will delve into their nomenclature and chemistry. So stay tuned and keep exploring with us. The nomenclature and chemistry of alkaloids can seem complex, but they follow certain rules. Let's dive into this fascinating world and demystify it. The nomenclature of alkaloids is primarily based on their origin or structure. For instance, alkaloids derived from plants are often named after the plant species they come from. Morphine, for example, comes from the opium poppy, Papaver somniferum, whose genus name papaver is derived from the Greek word papaveros, meaning poppy. In cases where alkaloids are derived from a specific part of a plant, the name may reflect that. For example, the alkaloid solanine is derived from the Solanum genus of plants, which includes the common potato. On the other hand, some alkaloids are named based on their chemical structure. The suffix "-ine" is commonly used to denote this group of nitrogenous compounds. For example, caffeine is so named because of its unique structure and not because it's found in coffee, although that's a happy coincidence. Now, let's touch upon the chemistry of alkaloids. They are typically derived from amino acids and undergo a series of transformations, including condensation, reduction, and cyclization to form their complex structures. This process is known as biogenesis. Alkaloids have a wide range of chemical structures, from simple molecules like nicotine to more complex ones like the anti-malarial drug quinine. The analysis of alkaloids, both qualitative and quantitative, is also an important aspect of their chemistry. Qualitative analysis helps identify the presence of an alkaloid, usually through color reactions, while quantitative analysis determines the amount of alkaloid present. Techniques such as chromatography, spectroscopy, and mass spectrometry are commonly used for these analyses. Understanding the nomenclature and chemistry of alkaloids is fundamental to their study and application. So, next time you sip your morning coffee or munch on a potato chip, remember the complex chemistry and nomenclature that's at play. Let's take a moment to reflect on what we've learned about alkaloids. These naturally occurring organic compounds have piqued our curiosity and continue to be a subject of fascination in the realm of chemistry. They are a testament to the power of nature's laboratory, found in a variety of plants and even some animals and fungi. We started our journey by understanding the definition of alkaloids. Remember, they are complex nitrogen-containing substances, usually with profound physiological effects on humans and other animals. They are the silent defenders of the plant kingdom, warding off predators with their bitter taste and potent effects. Then, we delved into the classification of alkaloids. We learned that they are grouped depending on their biosynthetic origin or based on their chemical structure. The primary classes we discussed include the true alkaloids, proto-alkaloids, pseudo-alkaloids, and polyamine alkaloids. Each class holds its unique characteristics and myriad compounds waiting to be explored. We also looked at the occurrence and properties of alkaloids. We learned that they are predominantly found in the plant kingdom, with over 20,000 known alkaloids, and each one holds a unique property. Some are medicinal, some are toxic, and others are psychoactive. They are incredibly diverse, from the colorless, crystalline structure of morphine to the vibrant hues of berberine. In our exploration of the nomenclature and chemistry of alkaloids, we realized that their names often hint at their origin or structure. For instance, morphine is named after Morpheus, the Greek god of dreams, reflecting its sedative effects. The chemistry of alkaloids is intricate and fascinating, involving a series of complex reactions to produce these potent compounds. In essence, alkaloids are a marvel of nature's chemistry. They serve multiple roles, from defending plants against predators to offering potential medicinal benefits for humans. Their diverse structures, intriguing properties, and the sheer breadth of their occurrence in nature make them a captivating subject for study. Alkaloids, with their intriguing properties and wide-ranging effects, truly are a testament to the wonders of nature's chemistry. Our journey into the world of alkaloids has only just begun, and there's so much more to discover. So stay curious, keep exploring, and remember, chemistry is all around us. Subscribe for more because you won't find me later.